I don't know. We'll figure it out. So basically, I did give this talk, kind of similar talk like this, about 2 years ago, just about C++. So we wanted to kind of respin that again, but I figured it might be more useful to kind of have some kind of goal or target for the presentation. So going to be talking about specifically kind of C++ in the context of interviews and technical interviews. So kind of mostly meant for people who are experienced with Java or C or other languages and kind of fairly new to C++. Going to be kind of assuming that. So I guess before I get started, just in the chat, like if people can just say like what year they're in, just so I can kind of get an idea of how much detail I should be going into things. U1, U2, U1, U3, U4, U3, U0, U2. So it seems like mostly like on average U2, U3-ish. So I guess in that sense, like some C knowledge, some mostly Java knowledge for most of you. Cool. So I guess introducing myself for those who don't know me, I'm Michael Sukkarieh. I'm currently a software engineer at Google, studying games and entertainment, specifically kind of on the graphics team, but at this point the team is so small that everyone's kind of just doing everything. So not really technically a graphics programmer, but almost. So previously I was at McGill Software Engineering, so I graduated last semester. I was also part of GameDev McGill for 3 years, I believe. And during my degree, I did interview at a bunch of different places for full-time and internships. So, mostly game dev interviews because I'm mostly interested in game dev. So, the traditional Ubisoft, EA, Activision, and Riot Games. I mean, you can see them all here. And then also some of the big tech companies like Google, where I'm working at now, obviously, and then Apple and Microsoft and stuff like this. So I'm hoping that I kind of have some knowledge with interviews, just because like interviews are something where like if you do more of them, you kind of get better at them. So I'm kind of hoping to transfer some of that knowledge and talk about that knowledge here. One disclaimer that I will add is that everything here is from personal experience. This talk is no way affiliated to Google or Stadia. I've never given an interview at Google. I'm not even interview trained, so I have no idea how that works from an interviewer side. So just a disclaimer out there. And I'll also only be talking about like C++ specific interviews. So you might have heard of like the traditional big tech interviews, which are around like algorithms and can you reverse a string and all that kind of stuff. That's also obviously very important. But that's not kind of the topic of this talk. The topic of this talk is specifically C++ interviews. So I guess before I guess in the next slide, so the big kind of differentiating factor, like if I go back to this list here, so I've done both of the kind of like C++ type interviews and like the more like general algorithm type interviews, mostly like Google, Microsoft, like Facebook, and these big like FANG type companies will ask you generic algorithm type questions where it doesn't really matter what language you do them in. Where if you're interviewing for a position that's usually specifically C++, like mostly pretty much every game dev position, Activision, Autodesk, it's not really game dev, but like sort of game dev. NVIDIA obviously being on like the hardware side was a C++ interview. So that's kind of, you would expect to have these kinds of questions in those types of interviews, whereas like an interview at Google or Microsoft probably won't ask you these types of questions, but it's kind of just better to understand this just in general for programming career. So the kind of goals of this talk are to be talking about the difference between C++ and C and Java, kind of introducing C++ from that point of view, and also then discussing aspects of C++ that are commonly asked during technical interviews. So there's a very broad topic. C++ is a huge topic, so I'm only going to be focusing on some certain things. So I wrote const correctness here. I don't know if I actually will get to talking about const correctness, but talking about memory allocation, bit twiddling, kind of like bit working with on the bit level, and dynamic dispatching, which is a huge topic for C++ interviews. And then hopefully, again, trying to make C++ less intimidating and more interesting, because I know C++ is kind of like not very talked about at McGill. There's only one credit class on it. Pretty much everything is in Java. So, and people kind of view C++ as this thing that like some people think that it's never used and that like it's some archaic thing, where in reality it's really not. It's super powerful and useful. So getting into the history, I guess you always got to have a history slide. So it was developed by this guy called Bjorn Stroustrup, this guy on the bottom right here, a long time ago. So it was basically meant to be an extension of C to add object-oriented programming. So it was initially supposed to be called C with classes, and then renamed C++. And since its creation in 1985, it has had a bunch of different updates, like they call them standards. So 2011, 14, 17, and actually one that was released this year. And these are usually prepended by like C++ 11, 14, whatever, C++ 17, which have additional features. I'm probably not going to be talking about the new standards, mostly just talking about fundamentals. Maybe if we have time, though, we'll get into those standards, but we'll see. So I guess speaking of that, like at any given point in time, if you have any questions, so I don't know, I'll just mention this again for those coming in late, but there's this thing, you can either ask them in the chat in Zoom. I won't be looking at that though, so like hopefully I'll be checking that every now and then. Or you can also go on this website that I just found right before this talk and use this room code. And I have that on the other screen. So if you ask a question, I should be able to see out there, and it's anonymous. So basically, if you do that, then I might be able to see your question better. And also, I mean, feel free to just unmute your mic and just interrupt me. Like I really won't be offended. I really would prefer this to be more of a discussion rather than just me like talking for an hour. Like the slides themselves are probably not going to fill an hour, and I really would prefer to have more of a discussion really than just me talking. How many screens do I have? I have two, unfortunately. Wish I had three. But in terms of industries using C++, they're used a lot. I mean, video games obviously being the big, in my opinion, the biggest one probably, because probably just for legacy reasons, because everything was written in C++, but obviously because C++ is more about high performance and efficiency, and also like being able to scale with huge code bases. Not people know that actually a lot of backend infrastructure at these big companies like Google and Microsoft are also built in C++. For some reason, people only think that Python and JavaScript developers work there, but like it's really mostly, I think, Google, one of the most used languages at Google, C++, financial applications, embedded systems, and all that cool stuff. But obviously, if you're in game dev, then probably the most interesting industry is video games. And yeah, so I guess we can get started on the C++ side. So very simple hello world here. Not very complicated. So you have hashtag include, just like in C, to include header files. You got namespaces, which I'll be getting into later, and a main method, just like in C, which is your main entry point. And then I'm basically just printing hello world into this stream, or you can just use printf. The details here aren't very important. Basically, the thing I'm trying to show here is that hello world is very simple in C++. I don't know if people think it's some scary thing, but it's very C-like. And that's what you'll notice first off when you try to go into C++, is that it's pretty much looks exactly like C. Like as long as you're not using any C++ specific features, it'll literally just look like you're writing C code. So it's strongly typed, unlike languages like Python or JavaScript. Question, why are you using namespace standard? I'll get into the namespaces later. But yeah, it's pretty much very similar to C. So it's there are some differences though, and I'll be getting to that now. So obviously C++ is object-oriented. That was kind of the whole purpose of creating the language. So, if you have experience with Java, you know about object-oriented programming, classes, polymorphism, all that kind of stuff. I actually don't know Java that well. I feel like I haven't touched Java in like so long. So I don't know if Java has constructors or destructors, but C++ allows you to have methods in classes that are called during object creation and destruction. So you can see here, actually, let me put the pointer on so you can see what I'm highlighting. So you can define a function that's the same name as the class, and this is called when an object of that class is created. And then if you had a tilde before, it's a destructor. So this is called when the object is destroyed. So, I mean, realistically, if you're in C, you could technically do this. You can simulate classes in C by having a struct that has function pointers as fields, and then having those function pointers point to static functions or what have you, and then have like int and dispose functions that are your constructor or destructor. But basically, in C++, which is really cool. So if you've used C, like if you're taking software systems, Comp 206, I think it was, you've probably used like malloc and free. So in C++, it's new and delete. So the reason behind this being that the majority of it, like you have constructors and destructors now that I've mentioned. So new is really syntax sugar around calling malloc for the size of the game for the object, and then calling the constructor. So I mean, you could still use malloc if you really wanted to, but calling new is pretty nice. And if you've used Java, which probably everyone here has, then you're already kind of familiar with this. But you basically have that now with C++. So questions: which IDE would you recommend? I use Visual Studio, but code is also pretty nice. Where's the VAX? I don't even know what VAX syntax. Oh, is that Visual Assist? that's Brendan for sure. Let me delete some of these questions so I don't have to keep looking at these fucking questions. Are those asterisk pointers too? Yeah, there definitely is pointers. So very similar to C, you have the concept of pointers that are variables that hold memory addresses. Very similar to C. Well, exactly the same as C. Which I'll be getting to kind of the difference between the Java section after. So one of the other things that C++ provides is generic programming. So I'm not sure if the intro to Java classes talk about generic programming, but I mean, if you've kind of used Java, you're probably familiar with the idea of generic programming. So it's basically the idea of defining a class that is uses an abstract type. So you basically instantiate different copies of that class for each abstract type. So you can have like generic containers that contain generic data types. So that's very powerful, and you can do that with C++ using templates. On the topic of templates, like there's a huge area of templates, like with meta programming and all this random stuff. I've never been asked a template question ever in a C++ interview, so I kind of just wanted to put that here to bring it up, but don't be too worried about this. I personally don't even really know how to use templates too powerfully. Are these slides going to be posted afterwards? Yes, I can definitely post the slides. Do we generally need a university degree to land a game dev job? I'm going to finish this and then I'll get to that. Maybe having the monitor with questions might not have been the best idea because I keep context switching here. But with namespaces, basically, so if you've used Java, you're probably accustomed to this idea of packages where you can contain code in different packages and they're existing in their own scope. C++, you can basically do that with namespaces. So namespaces, you're essentially creating a new scope to define that things can be defined in. So say, for example, here you have on the right, let's say you have a job manager in your engine and you have a job manager in your renderer, and you don't feel like renaming the class job manager, but you don't want the names to conflict, then you can create namespaces to basically create a new scope. So this engine's job manager is defined within the engine scope, and this job manager is defined within the render scope. And then when defining it, you can basically refer to the specific class or symbol or whatever symbol you want in that scope. So basically it allows for very easy code organization and a name conflict resolution. Again, probably won't be asked about namespaces, but I thought I'd just mention that here. And so this is kind of related to the previous question, why are you using namespace std? So C++, unlike C that I know of, has a pretty nice standard library. So if you're using Java, you're pretty accustomed to like the Java library where you can have like array lists and you can sort and you have strings. And if you've been doing assignments in C, you've had to like work with car arrays manually and like do all this shit manually, which is super annoying. C++ standard library basically implements all the basic functionality for you, so you can have like vectors, which are basically array lists, strings, sort methods, hash maps, all this kind of stuff, very well implemented for you. And basically, the reason this example going back, just like wrapping it all together, the reason I'm saying using namespace std here is because the standard library is defined within the std namespace. So by saying using namespace std, I'm basically saving myself from writing std semicolon semicolon cout. It's basically saying everything that is defined within that namespace is basically now defined within my global namespace in that program. Yeah, so I know I'm going super fast, and that's because this is kind of just background context. The really meaty stuff is kind of in the interview questions. So I'm going through this super fast, and I apologize for that. So I guess I can take a break here and just look at these questions that I have. Okay, Roy's just answering all my questions for me. Are the slides going to be posted afterwards? I answered that. So do we generally need a university degree to land a game dev job? I would say it's 99% of the people that I know, at least, that work game dev have a university degree. And this is mostly because the best way to get a career in pretty much any field in software engineering is to get internship experience. And it's pretty difficult to get internship experience without being part of a university, just because like it's easier to meet recruiters because there's recruitment events and stuff like this. So I don't think it's needed, but it's way easier to get a job with a university degree. But for example, like a counter example to that is I worked with one of the senior graphics programmers at EA that I worked with didn't have a degree. Like he didn't go to university. And now he's like a senior programmer. So there's definitely counter examples, but it's definitely way easier to go the university degree route. Why do you put braces on the same line? Because it's less code, less lines, so it's faster. So now, any questions related to kind of the difference between C and C++, I guess, before we move forward? And feel free to unmute your mic, by the way, if you want to ask over voice. Okay, so now for the good stuff, C++ versus Java, which most of you are probably more comfortable with Java than C. So obviously the biggest thing with C and C++ compared to Java is the idea of manual memory management. So with Java, you can kind of just call new, and then you don't need to care about deleting or managing your memory because everything, the Java runtime does that for you. Whereas, similar to C, in C++, you're allocating memory manually on the heap, and you have to delete memory manually on the heap. There's nice ways of doing this where like you technically don't need to do it manually if you're using like things called smart pointers, but I'm not going to be getting into that right now. If we have time, maybe I'll talk about that. But for the most part, the general thing to take from this slide is that you have to be aware of your memory. So if you've ever used C and had like memory leaks or null pointer exceptions because like you forgot to free things or like you freed things too early, all those things still exist in C++. On the flip side, obviously, like not using a garbage collector is obviously much faster than having to use a garbage collector. One of the big differences that I guess people who will first start from Java to C++ run into is in C++ you can have instance allocation on the stack. So this is also the same in C, but it's, from my knowledge, not the same in Java. So in Java, when you have user-defined classes or user-defined types, a variable of that user-defined type is a reference. So you're not actually allocating that object on the stack. You're implicitly kind of allocating it on whatever Java runtime heap that you're using, to my knowledge. So there's no concept of concrete stacks, concrete instances. you always have to say, game object equals new game object. You always have to call new, unlike primitive types like int and float, where obviously you don't need to call new for those. In C++, however, you can actually allocate instance user-defined types on the stack. So here we have some code where I have this class called game object, and I just define a new game object here, and this is allocated automatically on the stack. And obviously you can create a pointer to a game object and allocate memory on the heap. And these are different ways of going about allocating memory. These are super important to kind of get comfortable with, because allocating memory on the stack and allocating memory on the heap are obviously very different. And that's a very big topic of discussion with interviews. So getting comfortable with that was super important. I'll be getting into that more later. So, you know that like when you allocate things on the stack, they're implicitly deleted after the scope of the stack is ended. So here in this case, you have to explicitly delete this heap allocated memory, where the memory on the stack is deleted right after you return from this function, which is where the scope of that that instance was created. So if you're comfortable with C, like this is the same thing where if you instantiate a struct, it's the same thing. Like it's you can allocate it on the stack. So operator overloading is also a really cool thing that C++ provides. So in Java, like I used to hate using Java just because like even basic things, like if you have two vectors and you just want to add them together, like you have to use a function called like add on, like either a static function on a vector class or what have you to add vectors together. You can't just do vector plus vector, where in C++ you can actually do this by overloading operators. So in this example, I have a class called object, which has length, breadth, height, whatever, and you can actually overload the plus operator to do, this is the logic for adding two boxes together. You can do whatever you want here. And then in the future, you can just say box 1 plus box 2. So using this operator will implicitly call this function that you define. So you basically overloaded the operator. And this is really cool for being able to use operators on user-defined types. You can obviously also overload equals, which is super powerful, because equals is essentially, if you think about it, how you copy a user-defined type. So you can basically control how things are copied using the equals operators, which is super powerful. Or even you can even negate the use of equals. That's a super cool method for being able to basically restrict copying of certain types, which is also super powerful. Probably not the topic of interviews. That's why I'm kind of glistening over this, but still super cool if you're interested in learning C++. So I just speed ran through C++ versus C and Java, and now I'm going to actually be talking about interview topics related to C++. So I guess I can take a moment here to refresh these questions. Delete. Okay, my browser's frozen. So any questions in the chat? The JVM does escape analysis, which could put some of your objects that don't escape the scope on the stack instead of on the heap. Okay, yeah, I didn't actually know that. The key point there that being is that like everything is controlled by the Java runtime, whereas in C++ you have to do it manually. Why manually delete an object on the heap if it will be deleted anyway when the stack frame is popped? So that's an important topic. So let me go back in here. So the memory that's allocated on the heap is not automatically deleted when the stack frame is popped. The only thing that would be deallocated in that case is the actual pointer pointing to the memory that's allocated on the heap. If you actually want to delete the memory on the heap, you have to explicitly call delete, or use smart pointers, which I might be talking about later. So hopefully that answers your question. So basically, in summary, it won't be deleted anyway when the stack frame is popped. Any other questions before I get into the good stuff? All right. So the three topics I'm going to be talking about are memory allocation and management, basically program structure, working with bits or bit twiddling as it's commonly called, and dynamic dispatching. These are from my experience, like these are the things that I've mostly been asked about. And one thing to keep in mind, obviously, is that if you're applying for an internship, probably won't go as much in depth as if you're applying for a full-time position. Like, if you're applying for an internship, it could be very shallow level, like just asking very, very high level stuff. And then for, I've had full-time interviews where it starts at the shallow stuff, and then for 30 minutes, you're just talking about deeper and deeper and just going layer by layer down and getting more complicated. That's, from my experience, that's kind of how C++ interviews go, where it starts super easy and then they just keep asking you follow-up questions and getting harder and harder. So I guess one thing to also keep in mind is that don't memorize answers. Like, I'm going to be having some example questions, and I guess you can like theoretically just memorize the answer to these questions, but like you will get screwed if they ask a follow-up question if you don't fully understand kind of the background information on that. So memory allocation and management. So this is basically related to kind of the stack versus heap. So basically the thing I talked about before, working with bytes and potentially virtual memory. So kind of how virtual memory is implemented. You probably won't be asked about virtual memory and that kind of stuff in an internship interview. I don't think I have been, at least, but potentially for full-time, virtual memories is a cool topic to talk about. So all of this really stems from kind of the program memory layout. So you've probably seen this image in Comp 206. I don't remember which class introduces this. So basically how a program is laid out in memory. This is the non-virtual memory configuration. This is the most basic layout. And you can see here that we have this big memory block, which is used for the stack, and a big memory block for the heap. So this is for one program, and then each program will have, their own frame, basically. So you can see here in this example where, as you're allocating memory on the stack, you're using up that block, and as you're allocating memory on the heap, you're using up this block. One thing to keep in mind about like how the stack works in general is that, do I have an example? I think I have an example. Oh, I showed the, spoilers. Is there a way I can skip to that without showing the answer? Because there's a really good example explaining what I want to just talk about. But I guess I'll try to hand wave my way through this by the time we get to the example. One thing to remember with the stack is that the compiler, when you call a function and that function has variables defined in the function, the compiler knows exactly how much memory you need for that stack frame. So let's say you have, a function that takes in 2 integers, a float, and it allocates an array of 100 integers or whatever. Like the compiler knows when it's compiling that function, it knows exactly how much memory it needs to allocate for the stack. All those variables that are allocated to the stack. And that memory is allocated immediately when you call that function. So that's really cool. On the other side, the heap, obviously the downside of that is that it's fixed and you can't modify it. So if you want dynamic memory where you might not know exactly how much memory you want to allocate, like for example, if you're reading a file, for example, you can't just predict. You don't know at compile time necessarily how big the file is, so you have to allocate memory dynamically at runtime. So the heap is really good for that. So it's basically free memory that you basically request the OS to go fetch you. So you say, hey, operating system, I want 1 kilobyte of memory. It'll go find that for you and then send you back the memory address. So in this simple example, like it's super easy to see, this just go up. That's how you find the memory address. But in reality, in a real life application, the heap isn't just centralized into one memory block. It could be scattered around the memory. In a virtual memory configuration, you might have several pages all fragmented around RAM, and the operating system has to go fetch free pages for you. So with that being said, I guess we can try to do our first example question, which is, what is faster, allocating on the stack or on the heap? So I guess if you think it's faster on the stack, I guess just type stack, and then if you think it's faster on the heap, type heap, and let's tally up these. I wish there was a poll feature. Stack. Yeah, I wish there was some like kind of anonymous poll so people couldn't see other people's questions. Because that might, though there is a poll feature. All right, sorry. As people, you guys know, Zoom more than me, being the Zoomer semester. Yeah, I don't know how to use either, but I mean everyone said stack. You can ask people to private message you too. Oh, that might work. We can do that for the next question. So people are correct by saying the stack. As mentioned before, the stack block, or if you want, is allocated when the function is called, and you know exactly how much memory you want to allocate. So that's pretty fast, right? Because all of that is being allocated basically for free by the amount of memory being to be allocated is computed and done automatically for you. So it's super fast. Whereas on the heap, if you want some memory, you have to request it from the operating system. Operating system has to go find it for you and then give it back to you, which is obviously a much slower process. I'm the co-host again. Nice. So hopefully that was clear. This is definitely a question I've been asked before. So this could, for example, like in terms of like the complexity that you might be able to expect, maybe like at the highest level, like lowest level of complexity, highest level of abstraction, you might be asked, is it faster to allocate memory on the stack or on the heap? And you might just say stack, and they might just go, okay, cool, and they might move forward. Or they might be like, why is it faster on the stack? And then you might have to go into like talking about, okay, on the heap, you are requesting memory from the operating system. Memory has to go find pages for you or free pages or stuff like that. Whereas on the stack, it's done automatically by the compiler when the function is called, things like this. So they might expect you to actually go in detail depending on what kind of position that you're going for. So definitely review whatever class talked about this before a C++ to make sure that you're comfortable with this idea. This is my great example that I wanted to mention. So just to close this up, here's my function that allocates memory on the stack. So here, in this case, the compiler knows exactly how much memory I want, and it just can do that automatically for me when I call the function. Whereas in this case, I'm using malloc to allocate an arbitrary amount of bytes on the heap. So in this case, it would be much slower because I'm doing that at runtime. Operating system is doing that for me. Any questions related to that before we move on to the next topic? See if I can delete this while I'm waiting for people. A server unreachable or an error occurred. That's fantastic. All right, and I've exited. Hold on, sorry. Give me 3 seconds to rejoin my own online questions poll. Okay. So I don't see any questions on the thing, so hopefully that's because there aren't any questions and not because the thing shit itself. But so the next thing to talk about is working on the bit level. So one thing to kind of keep in mind when it comes to technical interviews in general is that technical interviews kind of just suck in general because like you're trying to, if you view it from the interviewer's or employer's point of view, like you're trying to figure out a way to test like this huge expanse of knowledge in 1 hour, and like it can be very hard to do that. So like most of the time questions that you're going to be asked are like kind of questions that require you to know some kind of deeper level of knowledge in order to even answer that question. So for example, like for this, like which is faster, stack or heap, like you can obviously just memorize that allocating memory on the stack is faster than the heap. But like if you were to explain that, you would need to know, okay, how program memory is laid out, how like actually allocating memory sort of works from like an OS point of view. So that's kind of a nice question to ask to test that kind of knowledge. But on the topic of working on the bit level, like I would say that this is kind of trying to test your idea of like knowing how memory is stored and handled. So this is kind of hard to do. So a lot of the times what people will
Michael?
just ask, oh, hey.
Quick heads up, the question website is broken. If you could keep an eye on chat for questions coming up, then that'd be great.
Oh, okay. Okay, so
Sorry
it
about
wasn't
that.
just broken for me. Yeah, no worries. I'll just check back the chat every slide. Yeah. So yeah, so basically like the way to test kind of your knowledge on like how memory is, like what even memory is, like the idea of memory being stored like as bits, are usually tested using like bit twiddling questions. So these are questions like that work at the bit level. So an example of this, for example, is if you're given a list of unsigned ints, so 16-bit ints, but you want a list of unsigned cars, which are 8 bits each, how would you do that? Anyone have any ways to maybe get started on this? Or any
I have an
tools that
idea.
you would use? Sure.
So they're both unsigned, right?
Yeah.
So if we have an array of some things with like 16 bits, we could just make it so that we're reading off like 8 bits at a time. Maybe I couldn't tell. Like I can't describe how I would do that right now, but maybe have some sort of sorry, I
Yeah, no worries, no worries. I mean, I think kind of Roy got into like a bit mem copy using Void Star. You could do that and then recast. I kind of didn't want to do that. There was another topic that I wanted to bring up. Reinterpret. Yeah, I guess ignoring like using cast or stuff. Like if you really just wanted to do it manually, what are some tools that you could use? Yeah. Okay. Peter kind of got to this. So using ands like bit and bit ors, masks, bit shifting, these kinds of tools. These are kind of things that you might want to use for kind of bit twiddling questions. So, and the question website just started working, so I'll get to those after this. So one super basic way of doing this would just be to use a mask and the bit end. Like this is super basic stuff, but like, you know, you can use a mask that fetches the bottom 8 and another mask that fetches the most significant 8, and then use bit end to extract it. That's one way. Obviously, like in a real setting, you would probably just use reinterpret cast or something like this, or some kind of casting. But being able to use bit end and bit or and shifting is super important. So another example of a question, I don't have it written here, but maybe people can kind of just like think about it. Maybe we can talk about the solution after. This is actually, I don't remember which company asked me this, but it was something like if you wanted to flip the even and odd bits in a bit vector, like in a 32-bit vector, how would you do that? So things like this where you kind of want to use masks and stuff like this. All right. So before I get into the virtual methods of dynamic dispatching, which is a huge topic, I'm going to, so flipping both the even and the odd. So basically making the odd bits where the even bits are and the even bits where the odd bits are. Is just another example of a question, a bit twiddling question. So some of these questions here. Is it true that allocating memory on stack is done at compile time and heap is done at runtime? So not really. Like, so, I mean, all memories, unless it's like static or constant memory, will be stored at compile time. But what I meant by like compile time is that at compile time, you know exactly how much memory needs to be allocated for that function. So when you call that function, that the compiler, the whatever runtime environment will already know how much memory needs to be allocated for that stack frame. So that's done automatically. But I mean, all the memory is allocated at runtime. Hopefully that answered. Do threads share the heap? That's kind of, yeah, I would, because like the heap belongs to the program, so threads belonging to the same program would probably share the heap. There's probably ways to kind of have non-shared memory, but so hopefully that answers that. Allocating memory on the heap is runtime while stack is compiled. So same question as before, like, no, it's all runtime, but the compile time aspect of the stack is that you know exactly how much memory you want to allocate when calling a function. So let's see if I can delete these that I answered. Hopefully it doesn't crash again. I think I crashed it again, but just to clarify, it's possible to overload equals so that two objects A and B with different memory addresses will return A equals B true. I mean, technically, like in that case, I think you're referring to the two equals operator, so like the comparison operator. And in theory, like you could overload the comparison operator to always return true. I don't know why you would do that, but like in theory, you could. Is cout? I assume that is saying what is cout. Cout is basically a stream that you can output to, and it defaults to the console. So it's basically the same as using in Java using system.out.println to print things on the console. Do we need to do elite code questions? I think it really depends on which interviews you're doing, right? So like if you're going for kind of like the traditional big tech internships, like Microsoft or Google and stuff, like you will need to do elite code because they will just be asking you algorithm type questions, where they probably won't ask you any like language specific type questions. Whereas if you're doing a game dev interview, so like EA or Ubisoft or whatever, they probably won't be asking you elite code type questions, or if they will, they'll ask you like very, very easy elite code type questions, like reversing a string or something. And they'll focus more on like the lower level, like C++ type questions or questions related to whatever specialization that you're going for. So like if you're applying for a graphics programming position, they'll ask you about like the rendering pipeline. If you're applying for a physics programming position, they'll probably ask you for whatever physics programmers do. I don't know anything about that. So things like this. I think that was all the questions. So the scope of the stack is only a block. So in the context of calling a function, like the stack frame of a function is all of the functions that are all the variables that could be defined in the function. In the context of allocation, deallocation, it would be in the block. So like in theory, like if you have like a for loop that declares a new variable, it'll be instantiated. Like instantiated is kind of a weird word to use here because like that memory is technically has already been allocated for you in the stack frame when you called the function, but that memory is used and then deallocated when you run out of scope. But I mean, in reality, the memory is still always there if you're still in the function. But it'll basically, you won't be able to use it when when you run out of scope. But the memory, the stack frame itself is deallocated after the function returns. So hopefully that answers your question. That was kind of a confusing answer, I know, but the thing to remember is like the stack frame holds the stack memory, which is allocated on function call and deallocated on function return. And then anything related to scoping, like if you're in an if statement, the scope within an if statement, the scope within a loop, like making sure that you're using a variable in scope and out of scope is really the job of the compiler. Like it's not really related to memory being allocated. So let me try to delete these questions and not crash this. Sorry, I can't seem to delete questions, so I'll just try to remember which ones I answered or not. So any other questions? Okay, if not, I guess we can move on to virtual methods. So we only have 10 minutes left, so I'll try to do this and then maybe have some time for questions at the end. So virtual methods and dynamic dispatching in C++, this is something that you will 100% be asked on. Like, this is the most popular topic of interview questions. And it can be really hard coming from Java to really know anything about this, because you don't need to worry about this in Java. So what exactly am I talking about here? So in Java, we know that we have, runtime polymorphism. And we know that, like, if we have a class, for example, A, and a class B that extends it, where, the parent class has some method, the child class overrides that method. It doesn't matter what the compile time type of the reference that we're using when we call a method. It only matters what the runtime type of the underlying object is. So what do I mean by that? But so, if we go into this actual example, I'm creating an object of type A, I'm creating an object of type B, and I'm declaring a reference of type A. So I first make it refer to A. I call the M1 method. I actually end up calling the M1 of class A, because I'm referring to an object of type A. If I were to change that, so I now refer to the object of type B, and I call the same method, I get B's version of M1, even though I technically still have a compile time type reference of type A, but that reference is referring to an object of type B. So this is stuff that you'll probably learn in like I don't know, like ECSC 202 or whatever, like Introduction to Object-Oriented Programming class. But this is what's called dynamic dispatching. So you can I like to think of it as like dynamic. Whenever I think dynamic, I think runtime. And so you can think of it as like the function that's actually called is determined dynamically or during runtime based on the runtime type of the object, not based on whatever reference type I have. So any questions related to dynamic dispatching? Because everything I'm about to talk about after this will not make any sense if dynamic dispatching isn't clear. And feel free to ask either in like the chat, or if you don't want to ask in the chat, you can ask it in the online questions.org thing. I'm gonna refresh that just because when I refreshed it, it suddenly worked. Open. So I don't see any questions. I don't know if that means that no one's asking questions or if the thing is bugged. But yeah, so that's dynamic dispatching, runtime polymorphism. So in C++, this is not actually the default. So in C++, the default is called static dispatching. So you can imagine what this means. Things are determined statically. So if we have the same exact example, you have M1, M2, M1, and defined in class B and in class A, and we do the exact same thing. When we call M1, now we have a pointer of type A, and we're pointing it to an object of type B. When we call M1, it will actually call class A's M1 by default. It will not call class B's M1. And this is static dispatching. And this is pretty weird if you're coming from like Java, because you kind of just get dynamic dispatching for free. But that's not the default in C++. So if you do want to have dynamic dispatching, you need to declare a function as virtual in the parent class. I defined it here in the child class, but really it's the parent class that matters in this case, because as we'll see later, that's how it's implemented. So now if we call M2, which is defined as virtual, it will call the proper method, in this case, class B's M2. Basically implementing dynamic dispatching. So how is this actually implemented? So I have no idea how Java implements it. I assume it's doing the same exact thing, but we have some details on how C++ is implemented virtual methods and dynamic dispatching. So basically, we use this thing called a vtable. And what a vtable is it's essentially a hash map that maps, I don't know exactly how it's implemented, but like you can really just think of it as like a hash map that maps a function name to a function pointer. So basically the name of the function to the actual implementation of the function. So obviously these values will map to different things, different function pointers for a different class's vtable. So in this example, we have a base class with function 1, function 2, and these two children that the first one overrides the first function, the second one overrides the second function. And you can see these vtables. So obviously in the base, the vtable of the base just points to the base's functions. D1's vtable for function 1 will implement the overrided function 1 implementation for D1. And for function 2, since we didn't override it, it'll still just point to the base's virtual function 2, and so forth for D2. So using this vtable, we can basically look up the actual implementation dynamically. That's why that's probably why it's called dynamic dispatching for the object. And so you'll notice here that like we actually implicitly, once a function has a virtual function, it will implicitly add this v pointer. So this is basically a pointer to that class's vtable. That, I mean, it would be probably a static pointer because all of the instances of that object share that pointer because they all share the same vtable. That was a lot of words. Basically, the thing to not memorize, the thing to understand is that we basically implement dynamic dispatching using this lookup table. So when we have a virtual function, the compiler knows. I like to think, like, I would highly recommend taking what is it called, compiler design, comp 520, because after you take comp 520, things are just make more sense from a compiler level. So I mean, you can really think of this as like, okay, if I'm a compiler and I see you calling a virtual function, right? I know that M2 is a virtual function. I can basically change this to being, actually don't just call M2, look up, dereference basically this v pointer to look up the value in the vtable for the proper function, and then call that function instead, right? So that's basically what's implicitly going on here whenever you're calling a virtual function. So the question thing is still broken, hey? What if I create a new one, actually? Hold on. Let me try doing that. I just created a new one. Let me type the code in here. So hopefully that won't crash. Maybe someone is just hosting this on their like home computer, and like as soon as 10 people got it, it just shit itself. But so that's basically how you would go about implementing dynamic dispatching in C++. So really, like, you can think of this as like, this is a very powerful concept just in general, like this idea of a lookup table for function pointers. Like you can do this in C, for example. Like you could technically implement, if you wanted to like implement classes in C using structs and function pointers, and then implement dynamic dispatching by like, you know, manually creating vtable pointers and then like dereferencing this. You could do that. One other common like thing that you could do these kind of vtable type designs is you can like have different APIs where you define the API basically using a list of function pointer, and like an implementation of an API could be just implementing a vtable. So like you're basically mapping the function to implementations for that API, and you can hot reload API implement. So this is a very powerful thing that like doesn't just apply to this. So understanding this is super important as well, but specifically in the concept of C++ interviews. It is almost time up, but like the last question I'd like to ask is, why would we want to set a destructor to be virtual? So if you remember, destructors are functions defined in classes that are called when the when the object is deleted. So why would that want to be? Why would you want to do that virtually, or define it as a virtual function? And I would, if you know C++, please don't answer this. I don't see anything in the online question, so if anyone wants to just unmute your mic and answer this, or anyone wants to type the answer in the chat. Nobody? No takers? Nice. So to deallocate objects specific to the subclass, exactly. So we remember before that, in the case of, you might have a child object that allocates some kind of memory, and you probably want to deallocate that memory on destructor time. So if the destructor isn't defined as virtual in the parent, and you have a pointer to the parent of parent type, then when you delete that object, you'll be calling the parent's destructor, not the child's destructor. So you have to make sure that the destructor is called virtual. It is defined as virtual. So that's a very common, very, very common question that's asked. Another question could be just like, how are virtual functions implemented, which is, you might have to talk about like how vtables are implemented. I think this is actually the last question. So that was a bait. This is actually the last question, which is, what is the overhead cost of calling a virtual function? So are virtual functions free, or like what kind of cost is involved? Anyone have any takers on this one? No takers. Maybe look something on isn't as efficient. Yeah. So basically, you're getting to that point where, as mentioned, basically in the implementation of vtables, like you're out looking up something in a table, which isn't free. I mean, it's not very costly, but it's not completely free. So basically, the answer is you're incurring a pointer dereference, because you're dereferencing that pointer to look up something in memory. That also might get sloppy because, as kind of Roy hinted to, like you don't know where that vtable is allocated. So like if it's in the cache, then great, it's in the cache and that's super fast. But like if it's somewhere where the memory has to, like the OS has to go load it from RAM, that might actually get costly if you're getting cache misses. Cool. MISC C++ concepts. These are all the things I wanted to talk about, but didn't get the time to. So I mean, they're in the slides. Feel free to look at them and then ask me questions later if you have any. But we're actually unfortunately out of time. But I mean, I'm still free if anyone has any further end of talk questions. And I don't have access to the online questions thing, so I'd ask everyone to please just put them in this chat instead. Or just speak up if you have any questions. So is vtable per class or per? Yeah. So as Roy hinted, like vtable would be per class, because the actual implementation, like there's no separate implementation of the functions for each instance. It's belonging to the class, so it's all static. But how much does dereferencing a pointer cost, right? So like that, hitting back to the concept, like if it's in the cache, then it would probably be super fast, right? Probably like very little. But if it's not in the cache and it has to actually look it up in RAM, then it could be pretty costly, hundreds of cycles. Any other questions? I don't see any questions. So I guess if there's no more questions, that's kind of it in terms of this talk. I have a bunch of other stuff I'd love to talk about, but I'm kind of out of time. So I guess with that being said, thank you all for coming, for attending my Zoom C++ talk, first talk I've given over Zoom. I guess if you have any questions regarding any of the content, feel free to reach out to me on Discord or on Facebook or whatever. I'll be happy to talk more about it. All right. Bye, everyone.
Yeah, just as a quick note, we'll have this talk recorded and we'll be posting it either on our Discord or since this is a public talk, after this talk. So if you want to review anything, it'll be there. And we'll talk with Michael about the slides afterwards. And I think you can send a few more questions in the Zoom chat before we end off. Yeah.
Sure.
you everyone for coming to this talk. And thank you, Michael, for your time.
All right, thanks, guys.